Hello everybody. There is a growing interest in quantum properties of the black holes and most recently in controversial discussion about the firewalls.
On the thermodynamic side, it describes how new developments allow the inclusion of pressure volume terms in the first law, leading to a new understanding of black hole as chemical system.
On the quantum information side, it should be learned that how basic arguments underlying the quantum complementary have been shown to be flawed, and how this suggests that how a black hole may surround itself with a firewall, a violent and chaotic region of highly excited states. So let's start with the BBC interview of black hole by Stephen.
From the outside, you can't tell what is inside a black hole. You can throw television sets, diamond rings, or even your worst enemies into a black hole, and all the black hole will remember is the total mass, and thus angular momentum, an electric charge. Quantum mechanics implies that the whole of space is filled with pairs of virtual particles and antiparticles that are constantly materializing in pairs, and then coming together again and annihilating each other. One member of a pair of virtual particles may fall into the hole, leaving the other member without a partner with which to annihilate. The forsaken particle or antiparticle may fall into the black hole after its partner, but it may also escape to infinity, where it appears to be radiation emitted by the black hole. The message of this lecture is that black holes ain't as black as they are painted. They are not the eternal prisons they were once thought. Things can get out of a black hole, both to the outside, and possibly to another universe. So, if you feel you are in a black hole, don't give up. There's a way out.
Hi everybody. First of all, we talk about the black hole and thermodynamics. The main objective to study this topic to understand the black hole mechanics and relate the law of thermodynamics with the law of black hole mechanics. The fundamental relationship between the gravitational thermodynamics and quantum theory comes from the hint of the black hole mechanics. About 40 years ago, a wealth of evidence has been requiring indicate that the law of black hole mechanics are equivalent to the law of thermodynamics, which apply to a system containing a black hole based on the quantum and classical theory. And based on the Hawking theory, there are the four fundamental laws which describe the black hole mechanics. Here we describe the first law of thermodynamics with the first law of black hole mechanics, which describe the first law of thermodynamics can energy equal to the heat plus work. If we have the first law of black hole, then the total mass equal to the K over 8 pi dA plus sigma dj plus psi dq, where J is the angular momentum and Q is the charge on black hole, where the sigma angular velocity and psi is the electromagnetic potential. Both evaluate the horizon area of black hole. If we say overall these terms psi dj and the sigma dj are thermodynamics work terms by the both law of, which is the first one is the thermodynamics law and one is the black hole mechanics law. which describe the PV term. Here the interesting question, why we add the PV, mean pressure volume term, add in the black hole mechanics term, which is the recent study says that the pressure volume term play very important role in black hole mechanics. The cosmological constant indicate a vacuum pressure P, in which it indicating the naturally thermodynamics pressure. In first law of black hole mechanics, the total energy of the system involving the energy and PV required to make room for it. In other words, we can say that the mass m is equal to R to create the black hole and place into the cosmological environment. Here we discuss another topic, which is the black hole as a chemical system. If we go back the first law of black hole mechanics, which is sigma dj plus psi dq, it's for the multiple rotating and charged black hole term. One of the first implications of the new perspective was realization that charged black hole behave as van der Waals fluid. The van der Waals fluid equation modifies the equation of state for an ideal gas to one that approximate. Here I am going to explain graphically, in which the well-known first order phase transition between radiation and large black holes can be understood as a solid liquid phase transition. The coexistence line in the diagram has no terminal point and is present for all value of A. As for new phenomena, both reacting phase transition and triple point has been found for black holes. In such graph, fluid behavior of charged black hole, the PV diagram, isothermal decrease in temperature from top to bottom, the two upper dark curve corresponding to the ideal gas one phase behavior for T greater than Tc, the critical isothermal T equal to Tc is denoted by the thick dark line, and the lower solid lines corresponding to a two-phase solid curve occurring for T less than Tc, for which the oscillatory part of the isothermal has to be replaced according to the Maxwell equation area law. According to the Maxwell equal area law. In this graph, reacting phase transition, the black hole in displayed by fixed pressure P, P1 and Pz, there is finite jump in its global minimum, indicating the presence of the zeroth order phase transition. As T decreases, the system follows the lower vertical solid red curve until at T equal to T1, it's joined the upper horizon solid red curve corresponding to small stable black hole and undergoes a first order large small black hole phase transition. As T continues to decrease, the system follows the upper curve until T equals to T naught.
Hello everybody. Today I am going to describe a very burning topic about the black hole. This is a so-called firewall question. This is a protective firewall, but a wall of dangerous, burning, high-energy particles that are surrounded in the center of the black hole itself. So, what is a black hole? The classical concept of black hole came from the Einstein general theory of relativity. A black hole forms when a star collapses and forming a region of space where the gravity is so strong that when you enter and passes a certain point, nothing can escape. So what that certain point is event horizon. When a particle is moving out there in space far away from the black hole, then it can move in any path and restricted only by the speed of light. Whereas when the particle comes closer to the black hole event horizon, then the space and time start to deform. And when the particle enters the event horizon, then it will not be able to return back. This is what the Einstein theory of relativity explains about the black hole. So why the black hole is important, and this is a not only a theoretical object, but it exists physically out there in space. And this is the region where the gravity is so strong that nothing can escape, not even light. So, as physicists, this is the nature of experimental physics, to move out there in space and watch the crazy science going into the black hole. So, for this purpose, an experimental physicist has to fall inside the black hole, but when it event horizon, then the tidal forces become dominant, then he will never be able to return back. The worst thing is that he will never be able to send us a message about the crazy science going physics. It is not actually liked by the physics. If we are near black hole and trying to escape, let's say by firing a rocket, then we see large number of dangerous burning high energy particles. The very same calculation says that if we relax and fall in, then we will not see any particle. So, for health perspective, it is better to just relax and fall freely into the black hole. But this is confusing, as the Einstein says that when someone falls into the black hole, then nothing special happens about the event horizon. The significance of an event horizon is that when you fall in, then you will never be able to return back. Whereas the new calculation says that when someone falls into a black hole, then he will see massive dangerous particles. So this is what the debate. So when you say that something is debate, then you actually don't know what is going on inside. Thank you very much for watching our video on the black hole. Hope you get some concept about the black hole and the firewalls.
Credit goes to the Dr. Abdul Majid, Associate Professor, Department of Physics, University of Gujarat.